So, if you're an engineer, you've definitely felt this shift, right? It seems like just yesterday, AI coding agents were, well, they were kind of clumsy, often really frustrating to use. And then almost overnight, bam, they got genuinely, shockingly good. So, the big question on everyone's mind is, how did this happen? How did they get so good, so fast? What was the secret breakthrough? And more importantly, what if I told you the secret behind all this new power is surprisingly simple? Well, today we're going to pull back the curtain and show you exactly how it all works under the hood. Okay, here's our roadmap. First, we'll talk about that sudden leap forward. Then we'll dig into the core philosophy of simplicity that's driving it. We'll peek inside the master loop, the engine of the whole thing, and see how they tame that dreaded context window. We'll take a quick tour of other top agents out there, and then we'll wrap up with 5 core principles you can actually apply to your own work. Let's do it. So let's get right to it. What was the big innovation? The huge reveal is that it wasn't some incredibly complex, brand new system. It was actually the exact opposite. The whole thing really boils down to 2 key breakthroughs. First, a move to a radically simple architecture. And second, the relentless, incredible improvement of the underlying models themselves. You see, the models just got so good at stuff like tool calling that they didn't need a complex system built around them anymore. The raw intelligence of the model itself just completely replaced the need for all that brittle, over-engineered scaffolding. And this leads us right to the core design philosophy, which you can sum up in one perfect phrase: less scaffolding, more model. The whole idea is to stop building these elaborate systems to work around the model's flaws, and instead just trust it. Trust it to figure out what file to read or what command to run, all on its own. And this comparison just says it all, doesn't it? The old way was this tangled web of complex, brittle engineering, directed acyclic graphs, RAG for retrieval, classifiers for intent. It was a mess. The new Claude Code way, it just scraps all of that. It's just a simple loop, better models, and a deep reliance on a few good tools. It's night and day. And this quote from the Zen of Python just hits the nail on the head. This isn't some brand new, crazy AI revelation. It's actually a return to fundamental engineering principles. The same ideas that make for good, clean code are the exact same ideas that make for a powerful AI agent. Okay, so let's pop the hood and look at the engine of this entire system. It is so simple, you could honestly call it a 4-line revolution. This is it. This is the whole thing, the master while loop. As long as the model is asking to use a tool, the agent just runs the tool, feeds the result right back to the model, and then does it all over again. That is the core. The real genius is that the models are now so good at navigating this simple loop that they can actually correct their own mistakes and figure out the path forward all by themselves. And these are the tools it's using. You can think of them as its senses and its hands. Read lets it see the code. Grep and glob let it search for things, totally replacing the need for a complex RAG system. Edit lets it rate code, but it does it smartly, using efficient diffs instead of rewriting whole files. Web search is really clever. It offloads information gathering to a cheaper, faster model. And to-dos are a neat little prompt-based trick to keep it on track. But the most important tool of all is Bash. Bash is the ultimate universal adapter. And why? Because there is an absolute mountain of human training data for it. The model is so good at using Bash because we are so good at using Bash. It can create Python files, run them, and then delete them, all inside this one single, incredibly powerful tool. All right, but every single agent developer has to face one massive enemy. It is the single biggest constraint on building long-running autonomous agents, and that's the context window. So what is it? Just think of the context window as the model's short-term memory. And when it gets full, the model starts to forget what it was doing. It loses track of the goal. It literally starts to get dumber. So managing this precious space is absolutely critical. So how does Claude Code fight this battle? It has a few really clever techniques. First, there's an async buffer. This decouples all the noisy terminal I/O from the model's core thinking process, which prevents junk from cluttering up its short-term memory. Next, a context compressor. Now this is really cool. When its memory hits about 92% full, this thing kicks in and smartly summarizes the beginning and end of the conversation, then just drops the middle. And maybe most powerfully, it uses subagents. This is like spawning a separate, smaller brain with its own fresh, clean context to go solve a subproblem. And then it just feeds the final result back to the main loop. It's an incredibly effective way to manage complexity. So That's how Claude Code tackles the context problem, but it's really important to know that they are not the only ones working on this. Other top-tier agents are out there exploring totally different philosophies to solve the same core problems, and there really is no single best way to do it. And this table gives you a great snapshot of the different philosophies in play. You have Claude Code, which we've seen is all about simplicity and being user-friendly with its master loop and reliance on Bash. Then there's something like Codex, which is way more powerful and low level. We're talking a Rust core and a kernel sandbox. Cursor IDE is all about speed and a seamless UI, which it gets from its own custom distilled composer model. And SourceGraph's AMP is fascinating. It's focused on creating agent-friendly environments with clever ideas like handoff to manage context. As you can see, it's all about making different trade-offs. So after this whole deep dive, what are the key lessons? What can you as an engineer actually take away from all this and apply today? Well, it really just boils down to 5 core principles. Let's just walk through them real quick. The 5 big takeaways from everything we've looked at. Number 1, trust in the model. Stop trying to build complex scaffolding around it and let the model's own intelligence drive the process. Number 2, simple design wins. That 4-line while loop is the perfect proof. It beats brittle, over-engineered systems every time. Number 3, Bash is almost all you need. It's the ultimate universal adapter. You don't need 1,000 custom tools. Number 4, context management matters a lot. Techniques like subagents and compressors show that you have to be smart about managing the model's short-term memory. And finally, number 5, different perspectives matter. There's no silver bullet, and the best ideas often come from seeing how others are tackling the same challenges. Which really leaves us with one final thought. If the central lesson from all of today's most advanced coding agents is to trust the model, then the real question for all of us is, how much are you willing to trust it in your own projects? Something to think about.